18.3, acid deposition. Okay, so now we get a little bit more specific with wet and dry deposition, etc. A lot of this we already covered in the last session, last recording, because that was quite extensive. So let's see, acid deposition. So sources, we've got anthropogenic sources, there are some natural sources, because again, the acid comes from, it's a secondary pollutant, which comes from NOx and SOx reacting with water and sunlight in the atmosphere. So we do know NOx and SOx are, I feel like I'm talking about like Fox and Sox, the Dr. Seuss book. Good God, my tongue is like, bleh. Fox on Sox, Sox and Box on NOx. Anyway, so NOx and SOx, okay, can come from natural sources, fires, volcanic eruptions, and from anthropogenic sources to react with light and water in the atmosphere to produce acid. So, wet deposition is considered a secondary pollutant, okay? So acid rain and all of our acid products that we're going to talk about are considered secondary pollutants. So the primary pollutant from which they originate are SOx and NOx. So let's quick review. SOx comes from what? Burning of coal, good, in the power plants. NOx comes from gasoline, very good. They react with water in the atmosphere and sunlight to make sulfuric acid and nitric acid. Okay? So it consists of SOx, NOx mixed with rain, snow, fog, any type of precipitation, water precipitation. Okay? The ones that hang out as acid rain, right? Because clouds can hover in the atmosphere for extended periods of time. It may take anywhere from 4 to 14 days once these secondary pollutants are made for it to come back to us in the form of acid rain. So therefore, right, just because you're polluting, one area is highly polluted, right, doesn't mean that they're going to be the ones who suffer from that acid rain, because it may drift and go somewhere else. Bam, look at that. pH, it's got to be less than 5.6 for it to be considered acid rain. Dry deposition. Okay, again, considered a secondary pollutant, just like over here, caused by the same two compounds, SOx and NOx. Reacts with water in the atmosphere to make sulfate and nitrate salts, so these solid particles. Now, because they're solid, do you think they will fall out faster or slower than the rain, which could take 4 to 14 days? If you said it would happen faster, then you are correct. So these suspended particles can fall down as dry deposition. They fall out of the atmosphere, and that can happen in 2 to 3 days. So usually the dry deposition falls closer to the source, the emission source, than your wet deposition does. But that makes sense, right? That makes sense. You don't have to memorize it because it just makes sense. So in summary, caused by SOx and NOx, they react with water in the atmosphere to make sulfuric acid and nitric acid. Okay. We also have the suspended particles, the salts, that can fall as dry deposition. The suspended particles will fall 2 to 3 days close to the emission source. The wet particles will fall 4 to 14 days later, usually away from the emission source. Normal rainwater can be somewhere between 5 and 6% to be acidic. The last slide said 5.6. I apologize. I need to go back and I need to change that. I apologize. So acid rain's got to be less than 5. It's got a pH of less than 5 to be considered acid rain. When it falls to the earth and it lands in the soil, for example, right now you've got an acid that's in the soil. So sometimes what happens is if there are products in there, calcium-based products, calcium carbonate, is present in the soil, they act as a buffer, meaning they go to then neutralize the acid, right? So that's a good thing. However, it depletes some of the soil nutrients out of the soil. Sorry, phone away stable. Depletes some of the nutrients out of the soil, and they're no longer available for plant use. So long-term exposure to acid can deplete nutrients, which can then lead to, what's what I'm looking for? Less good plant growth? That's horrible English. There's a better way to say that, and I can't think of it. So, leads to less good plant growth, and then if your plants are suffering, they may die. Because they die, you lose the roots that hold on to the soil, so that could lead to increased soil erosion. Increased soil erosion could then run the soil particles into a nearby river, which could then increase turbidity, which could then decrease the amount of sunlight reaching plants in the benthic zone, which could then decrease dissolved oxygen, which could then lead to fish kills, and it just goes back and back and back and back. All right. We can add, and they actually do this, to areas in the Northeast, because the Northeast is usually considered the industrial sector of the United States. So they've got high levels of acid rain, and they will go through and add in certain farms calcium carbonate to it, so that when it's plentiful. So when it rains, it reacts with the acid rain and buffers it, so it's not leached out of the soil. This you can find on page 481. Take a look at it. It's good. Maybe you want to try and draw it into your notes. It just kind of takes you through the cycle that we just went through. Environmental impacts of acid deposition. That is a tumor in that right-hand picture. This tumor right here. I know you're thinking, why is there a tumor there? I'll tell you in 1 second. Come on in. Come on in. I'll be done in 1 second. So sterilization of lakes and forests. So for a couple of things, one, the acid gets in there, and there's calcium found in the lakes, and it leaches that calcium out, which some of our invertebrates need to form their exoskeletons. And we know that the burning of coal, right? Coal has lots of mercury, also has radioactive particles in it. Once it's burned, these things can settle into land or aquatic environments and wreak havoc. It's also why a lot of your fish, when you test them for fish, test the tissue of the fish, they have mercury, high mercury content. A lot of that comes from the burning of coal. Reducing the population of small invertebrates and decomposers. They're very susceptible to these changes in pH, plus they need the calcium carbonate. Reduces agricultural yield. We already discussed that, right? Because the acid rain lands on the ground. The nutrients in the soil buffer the acid, thus depleting them out of the soil so the plants don't have access to them. In China, 30% of the croplands suffer from excess acidity. Again, that would have happened in the Northeast if they didn't go through and add the calcium carbonate preemptively to act as that buffer. Acid rain will corrode anything we put out as humans. It's going to interact with and corrode. Degrades water supplies by leaching heavy metals from the soils into drinking water supplies. Some of the reactions that take place in the soils with the acid that falls, that will combine with heavy metals, form larger particles that then erode quickly into the waterways during a rain event. And lung cancers, we already know this, burning of fossil fuels, coal, you get those ultrafine particulates, and acid deposition comes in, where I just lost train of thought because two other people just walked in, I apologize. I don't know. Increases lung cancer, acid deposition. There's a tumor. Good. All right.